Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay.
And I am your host, Beth Johnson.
And we are here to put science in your brain. We work very hard with this show and with our sister shows, Astronomy Cast and Vision Cosmica, to talk about astronomical research that is grounded in observations. While we do cover a lot of computer models and theory papers, they generally are simulations that are confirmed by observations. Sometimes, though, we have to recognize that the things our models reveal occur so fast that we might never manage to catch an event in real time. And we accept what model after model shows as being true because, well, everything makes sense and there are no contradicting observations. Consider star formation. Stars form in dense clusters where everything is in motion. Computer simulations and basic reasoning have long said that these environments, like busy city streets with broken traffic lights, should be rich in near collisions. With stars, these near collisions can toss about planets, trigger comets, and otherwise make a hot mess of a young star system. It all made sense. It just was, no one had ever seen it happen. But sometimes we all just happen to get lucky with the timing of our photos. And one of those collisions has now been observed by the Very Large Array and Atacama Large Millimeter Array. This system, Z Canis Majoris, was distorted during the event with a long arm of gas now reaching out toward the side-swiping star. According to project researcher Hal-Yu Baobab Liu, these perturbers not only cause gaseous streams, but may also impact the thermal history of the involved host stars like Z Canis Majoris. Project lead Ru Bing Dong adds, studying these types of events gives a window into the past, including what might have happened in the early development of our solar system, critical evidence of which is long since gone. Watching these events take place in a newly forming star system provides us with the information needed to say, aha, this is what may have happened to our own solar system long ago. Right now, VLA and ALMA have given us the first evidence to solve this mystery, and the next generations of these technologies will open windows on the universe that we have yet only dreamed of. This work is published in Nature Astronomy.
Astronomy and planetary science advance one spacecraft and ground based observatory at a time. Sometimes it feels like the engineers give and the gremlins take, and this is one of those days. The 17-year-old Swift Space Observatory is a workhorse for gamma ray burst discoveries. It has the ability to take images with 3 telescopes that sprawl the electromagnetic spectrum from gamma rays to visual wavelengths. This allows it to spot events in high energy gamma ray light and then identify their exact location precisely with the X ray and visual ultraviolet telescopes. With age, spacecraft do wear out, and it looks like one of the 6 reaction wheels on board has finally worn out. The spacecraft has entered safe mode. Reaction wheels are used to point space telescopes, and over the years, NASA has expertly gotten past missions to work on as few as 2 reaction wheels. It is hoped that Swift will similarly be able to get back to work and to continue its amazing science quickly. While Swift struggles, we see JWST preparing to hit its next big milestone, arriving at its destination, the gravitational sweet spot beyond Earth where the poles of the Sun and Earth will allow it to pace us in orbit around the Sun. On Monday, JWST will fire its engines to make its final course corrections into its parking orbit in this busy spot full of missions, including Gaia, Planck, and the now quiet Herschel.
Just as we were finishing up today's show, we got an update on news from earlier this week. On Tuesday, I said it was time for Starlink to show its mettle and step up to help with communications in disaster situations. According to Bloomberg News, Elon Musk is offering to send Starlink terminals to Tonga. We can only hope that this happens and that this is an aid package and not a business package. As we learn more, we'll update you here on the Daily Space. After the break, we'll be back with Beth taking an in-depth look at exoplanets. Stay tuned.
And now for all the exoplanet news you can handle. First up, MIT's Kavli Institute for Astrophysics and Space Research announced yesterday that the TESS Object of Interest (TOI) catalog has passed 5,000 planet candidates. I think that means it's only a matter of weeks before the confirmed exoplanet count surpasses that mark as well. As it stands, per the Exoplanet Archive, there are 4,903 exoplanets as of January 10th. Currently, the TESS mission is in its first extended mission, which is expected to run until at least 2025, and their catalog of candidates has more than doubled in the past year. TOI manager Catherine Hesse noted, data from the first year of the extended mission, we have found dozens of additional candidates to TOIs found during the prime mission. I am excited to see how many multi-planet systems we can find during the rest of the extended mission and in upcoming years with TESS. Congratulations to the TESS team. We look forward to thousands more candidates in the future. When it comes to exoplanet discoveries, I've remarked several times in the past few months that we have reached the point where the only discoveries being announced with press releases are either massive data dumps from machine learning programs or these strange, weird, and unusual discoveries. This story is definitely the latter. Undergraduate student Emma Sofich from Arizona State University recently led a team that studied data in the Backyard World's Planet 9 citizen science project, and they found a brown dwarf binary system. Finding brown dwarfs is pretty amazing in and of itself, but this system has even more going for it. It's the most widely separated pair in a binary system ever found. The two planets, failed stars, are 129 astronomical units apart. The system is called CY's J014611.20050850.0AB, and the results were presented at last week's American Astronomical Society press conferences, with a paper to be published in the Astrophysical Journal. Also announced at last week's AAS press conferences was the discovery of 3 planets who are teetering on the brink of destruction because they are orbiting dangerously close to their parent stars. One of these planets, TOI 2337b, has less than a million years to survive, making it the most endangered known planet. The threatened planets were found in NASA TESS image data from 2018 and 2019. Follow-up observations were performed using a spectrometer at the Keck Observatory in Hawaii to confirm the planets. In a paper accepted to the Astronomical Journal, researchers presented detailed estimates of the planets' masses and sizes, with mass ranges 0.5 to 1.7 times Jupiter's mass, and size ranges from just less than Jupiter's size to 1.6 times its size. Basically, a bunch of Jupiters, really. Gas giants everywhere. Densities for the planets range from styrofoam-like to about 3 times as dense as water, which means these planets also have different origin stories across the board. That's pretty cool and kind of frustrating because it adds more complexity to our planetary formation hypotheses. Honestly, there may be too many variables to come up with one cohesive formation theory. We're likely to have to tailor potential outcomes based on the parent star's age, type, how big the planet protoplanetary disk was, which way the winds were blowing through the gas cloud that formed the star itself. I could go on and on. But the main objective in studying these 3 planets and the potential hundreds to be found later is to understand the end of life for a planet. Per the press release, current models of planet dynamics suggest that planets should spiral in toward their host stars as the stars evolve over time, particularly in the last 10% of the star's lifetime. This process also heats the planets, potentially causing their atmospheres to inflate. However, this stellar evolution will also cause the orbits of planets around the host star to come closer to one another, increasing the likelihood that some of them will collide or even destabilize the entire planetary system. Now we wait for some time on JWST to gain some insight into what the planet's atmospheres are made of: water, carbon dioxide, etc. That would help researchers put some constraints on the formation of these worlds and what sort of interactions might have led them to where they are today. Planetary formation, it seems, is messy. After the break, we'll go to Pamela with some really awesome astrophysics imagery. Stay tuned.
Space is messy. Gas and dust obscure a lot of cool objects behind walls of either opaquely dark or heinously bright materials. And while we know there is stuff in and behind the mess, figuring out what it is requires a fair amount of sleuthing. Sometimes we get lucky though, and the hidden objects make themselves known by screaming out flares of light and material that point back to dramatic events. Baby stars, like human babies, are particularly good at screaming. Recent observations by the Gemini South Telescope looked at a variety of regions containing star formation, and in two very different environments, young stars found ways to make their presence known. The system, MHO 2147, is a cold, dark cloud that blocks the light from objects inside and behind it. We know this system hides a young star that is spinning like an unstable top because we see a pair of helix-shaped jets. As material falls into the young system, it forms a hot disk and the star generates a magnetic field that, in turn, flings material out in jets. The jets point in the direction of the star's rotational pole, and these helix-shaped jets mean that star is slowly tracing out a circle with its pole, just like a top spun imperfectly may do. In a very different region of the sky, MHO 1502 lurks in a bright region of ionized hydrogen gas that is heated by young massive stars. This system is spinning out a dashed line of material, indicating that whatever is happening is turning on and off with time. It is thought the system is actually two stars. We all leave traces as we move through our lives, both humans and stars. And sometimes a lot can be learned from these traces, even when we do our best to hide. The gas in both those two systems will someday be exhausted as stars form, planets form, and together they draw material from their surroundings and use light pressure to blast away any leftovers. Over time, our galaxy will stop forming new stars unless new gas is introduced, and a new paper published in the Astrophysical Journal and led by Sanchita Boraka indicates that our Milky Way will have the ability to refuel at least for a little while. Using archival data, she found faint traces of gas in the space beyond our main galaxy. She explains, observations of galaxies are similar to looking through an airplane window at night and seeing bright city lights surrounded by darkness. Finding this fuel source is like discovering that in the darkness lies the farms and supply routes that support the population in the cities. In follow-up research, Bathaker plans to study how that gas can fall into the Milky Way and make its way all the way to the galactic core. She goes on to explain, galaxies like ours will continue to grow by forming many more solar systems as new material comes in. Understanding the source of the star fuel allows us to predict if new stars will be formed in the future. It is amazing what can be found in the archival data set aside by numerous telescopic surveys. It is also amazing what you can see for yourself with just a good lens and a tripod. Next up, Eric Mattis will be presenting a review of a Canon RF 24 to 240 millimeter all-in-one zoom lens. Stay tuned.
The lens I'm going to be reviewing this week is yet another lens for Canon's full-frame mirrorless system, the Canon RF 24 to 240 all-in-one zoom lens. I got this lens as part of a kit with my EOS RP. You usually see all-in-one zooms like this on an APS-C camera. Indeed, when I had a Nikon D3100, a DX18-300 was on it almost all the time. I like the 24 to 240 millimeter range because I can be out taking relatively wide angle shots and still have a lot of reach with just a twist of my wrist if I see some animal. The purpose of a lens like this is to cover almost all of the focal lengths you may need in one convenient package so you don't need to change lenses while out. Many people could be fine owning just this lens. The compromises you make to get this capability are cost. The lens is $900 itself, less when purchasing a kit. Weight, it's 750 grams, and small aperture. It ranges from f4 to 6.3. For the longest time, this was the only lens that I had for my camera, and I was frustrated by needing to crop a lot for wildlife. But that's not the purpose of this lens. A few months later, I got my 600mm prime made for wildlife and loved it. Since getting the 600, I've hardly used this one, less than 500 pictures in a year versus nearly 2,000 the 600. I also prefer primes because the industry standard clockwise zoom rings aren't comfortable for my left-handedness. The usability of this lens is better than its image quality, except for when you need manual focus. It has great build quality, but typical for a non-L lens, there is little to no weather sealing, so don't go dunking this lens in the mud. Zoom ring is most of the lens's length, so it's very easy to make small adjustments. I don't notice any zoom creep when having it vertical, but there is a lock button that keeps the lens at 24 millimeters, which I use for storage. It's relatively compact when fully retracted. Like other cheap RF lenses, it has a combination manual focus and function control ring with click descents. This requires the user to dig into the menus to choose manual focus and reverse the process to go back into autofocus mode. However, the 24 to 240 has Canon's top tier and accurate nano USM autofocus motor, so you never need to switch into manual focus unless it gets very confused. It's unusual to have a lens with such a wide focal range on a full frame sensor because the lens must cover a bigger image circle. All-in-one lenses also usually have lots of distortion of different types along the focal length ring, and oh boy, does the Canon RF 24 to 240 have distortion. I've talked a lot about the image quality of this lens in reference to others that I've reviewed before, but here's more detail. 24 millimeter, the lens image circle doesn't cover the full sensor, so the dark corners are black, which is not good. So the camera processes the image to make it cover the full sensor, leaving them pretty soft and low res. But the rest of the image is pretty sharp, and the colors are good. And the image is digitally stretched until about 70 millimeters, and it's good for the rest of the focal range, 240. And of course, there's barrel distortion at the telephoto end, but that's not as bad as the completely black corners on the wide end. And all of this distortion is corrected in camera, so you'll never notice it unless you shoot RAW, which you should, and edit in non-Canon software. My biggest problem with this lens, and why I can't really recommend it, is its size and weight. It's 750 grams without hood and 122 millimeters long collapsed. It plus my RP and strap just barely fit in a normal size camera bag, making it a hassle to get out and making me leave the bag with its spare batteries and memory card in the car. This size is also awkward to carry around. I usually have to keep a hand resting on it to prevent everything from swinging around when I'm walking, even with it cross-body. Another thing is the lens hood is fiddly to put on to remove, so I keep it on all the time, which makes it even longer. Unless you really need this focal range in one lens, I would recommend getting the smaller and lighter 24 to 105 f4 to 7.1 and spending the money you saved on a RF 100 to 400, a lens that didn't exist when I first got this camera and lens. The RP is a pretty small camera, so it doesn't really make sense to pair it with a bulky lens like this 24 to 240. The 24 to 105 f4 to 7 is a good lens for what it is, but it's more expensive than I think it should be. However, you can get it for a reasonable price as part of a kit, or even cheaper than that, used. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.